Hello everyone, how are you all? Welcome to Deeksha, Karnataka. I hope everyone is doing well. Please let me know if I am audible to you, then I can proceed. And before I start, just wanted to tell you that today again we are going to solve top 20 MCQs from the chapter alternating current. It is KCET previous year questions. Okay. So top 20 KCET previous year questions from the chapter alternating current, and it will be important chapter. You generally get 3 to 4 questions from this chapter. Some concept of this chapter is definitely now deleted, so if you see some questions, if you have a PYQ book and if you see some questions are not discussed in today's session, that means you can assume that those questions are now deleted. Okay, so for example, Q factor related questions, some resonance frequency related questions are deleted. Not all resonance frequency is still there in the syllabus, but Q factor and resonance related questions are not part of the syllabus. Okay, so first question from 2025. And you can see the level of the question. It is very easy question. So most of the questions coming from this chapter are medium question, but there will be at least one question which should be considered easy, and you should be able to answer them without much difficulty. So in domestic electric mains supply, the voltage and current are DC voltage, DC current, DC voltage and AC current, AC voltage and DC current, or AC voltage, AC current. So the current that we use in our day-to-day life, so what is the nature of that current? AC voltage, AC current, or DC voltage, DC current? That is the major thing that you have to guess. So if you don't know, let me give you a hint. The thing that we use generally have 220 volt, 50 hertz, that is the current voltage that we are being used. So that means it is an AC voltage. Now if there is an AC voltage, we cannot make it to AC, cannot make it DC current directly. We have to use converter to convert it. So basically AC voltage and AC current is the thing that we use in our day-to-day life. So the domestic electric supply always sends you AC voltage and AC current. It is easier to manage, right? You can send over long distances, you can send high voltage and low current, but when it reaches to your home, the voltage value is reduced and then current value increased, and thus it is transferred to your household. Okay, so AC voltage, AC current is the answer. Adi is saying option B. No, Adi, option B is not correct. We use AC voltage, AC current, okay, because it is easier to transport. AC voltage and AC current always has to be in pair. Okay, DC voltage, AC current, AC voltage, DC current, these are not possible in general. Okay, in general either DC voltage, DC current, or AC voltage, AC current. Okay, and we do not use DC in our day-to-day life. So there is a time when Tesla and Eddington, they were fighting who will do AC or DC, which is better. So there are some experiment by Tesla, and later on it decided that AC is much superior than DC, and slowly AC taken over over DC. Okay, now next question. Very interesting question. So as you can see, the values are given a little odd so that you can solve it without using a calculator. That is the main purpose of giving you the values, which can be calculated without using calculators. A sinusoidal voltage produced by an AC generator at any given instant t is given by an equation V equals to 311 sine 314t. So as you can see, the values, as I mentioned, are not typical, but it is given in a weird form. The RMS value of the voltage and frequency of are respectively. So let's guess who can guess the correct answer. Let's see. So correct, how to calculate the RMS value and RMS frequency. So first of all, you have to remember that the expression for voltage normally is given by V naught sine omega t. Okay, what is VRMS? VRMS is given by V naught by root 2, whereas the frequency is given by 2 pi f equals to omega, or f equals to omega by 2 pi. Okay, so omega value is given over here as 314, v naught value is given as 311. So what will be the answer? 311 by root 2, very interesting value. But if you know that when we have said that there are multiple times this value came, when we said that 220 volt is our power supply, the peak value of 220 volt is 311. Okay, so if you divide it by root 2, that is 1.41, so you will get that 220 volt. You can calculate it, but if you remember it, it will be much easier. So when you multiply, basically 311.1 is actually 220 root 2. Okay, so this is a value you can remember. So once you divide 311 by root 2, you should get 220 volt. Okay, so 220 volt is the power VRMS. But what about the frequency? How to calculate the frequency? To calculate frequency, what we have to do? We have to put the value of omega. Omega value here is given as 314. Okay, and pi value is obviously we know it is 3.14. So pi value is 3.14, 314, that's why it is given such as this value. So 314, you can cancel it and you will get 100 over here. So if you multiply 100 and 3.14, you get 314. So when you divide that 314 divided by 3.14, you should get 100. But there is also 1 2 over here, so these two will also cancel and you get this as 50 hertz. This is the exact domestic current supply that is being supplied to our homes. Okay, so 220 volt 50 hertz is the correct answer. Okay, in fact, if you are confused how can you solve it, you can do back calculation in case you don't know what is the value here. So what you can do, you can take the value of root 2 as 1.4 and multiply, do back calculation, multiply with 220, multiply with 200. Okay, whoever gives you the closest value, that will give you the exact answer. So in this case, if you take 200 volt, if you multiply with 200, you should get about 280. So obviously 280 and 311 is not matching, so definitely other option is 220, so this must be 220. That's how you can eliminate the answer as well. Okay, so there are two options I told you. One, you can remember it like this way, that's 311.1 is actually 220 root 2, or in case you forget, you can multiply root 2. Root 2 value is 1.4 approximately. You can take that value and multiply with 200 and see 280 is the value, but 280 is not given here. That means definitely this is not the answer. The correct answer will be 220 volt. Okay, these all question came in 2025. But before I go into any other further, I just wanted to tell you that if you are watching our channel, hi Upcon, okay, Upcon G2W, hi, yes, hi to you as well. So join the Deeksha WhatsApp channel. The link of the WhatsApp channel is given in the description section of this video. Also, if you are not yet subscribed to our channel, definitely I request you to subscribe to our channel and also share this link of this live video right now along with your friends so that they can come also and they can also learn something from this lecture, right? We always happy to teach you, and we always take pride that we always give you the correct answer, right? And WhatsApp channel is there you will get all the updates, all the notifications, also the PDF lectures, everything will be supplied through our WhatsApp channel. So don't forget to join the WhatsApp channel, right? The link of the WhatsApp channel is given in the description. But before going into there, first of all, you have to subscribe to our channel if you have not yet subscribed, right? Now let's move on to question number 3. Again, this is from 2025. A series LCR circuit containing an AC source of 100 volt has an inductor and a capacitor of reactances 24 ohm and 16 ohm. Okay, so So it is mentioned that capacitance and inductance both are provided respectively. If a resistance of 6 ohm is connected in series, then the potential difference across the series combination of inductor and capacitor only will be. So let us understand this question first. Here we have a inductor, a capacitor. First is inductor. Inductor means this coil is inductor. There is a capacitor. Also we have a resistor. Okay, so L, C, R, and they are connected across an AC source of 100 volt. Okay, now frequency is not given, but what they have given is the value of the reactances. This is 24, this is 16, and this one is 6. Okay, so these values are already given to you. So these values are given to you, and they asked you what is the voltage difference across the combination of inductor and capacitor. So if you put a voltmeter across the capacitor and the inductor, what will be the reading? Okay, only we are measuring the voltage across inductor and capacitor, right? So how to do that? So very interesting question. In general, we calculate XL, we calculate XC, then we calculate impedance, right? In this case, XL and XC both are given directly. You don't need to calculate XL and XC because it's a competitive exam, because you don't have too much time to solve it. So XL and XC, they are already given by the exam authority directly to you. Okay, so what is the impedance? Impedance is given by square root of R square plus XL minus XC whole square. So we will directly calculate the impedance of the circuit. So R square is 6 square and XL is 24, XC is 16 whole square. So 24 minus 16 is equals to 8. So 6 square plus 8 square. So this is very common in mathematics. If you have solved some mathematics, this is gives out to be square root of 100. So this will be 10. Okay, this is a very common number, right? 6 square plus 8 square, 6 square is 36, 8 square is 64, 36 plus 64 is 100. So square root of 100 is 10. Okay, clear? So this is a very common square root in mathematics. Now, so this value is known and this value is 10. So impedance is calculated. Now you have to calculate the current in the circuit. Current is given by the input voltage divided by the impedance. So input voltage is 100, impedance is 10. So current in the circuit is 10 amperes. So 10 amperes is the current in the circuit. Now you have to calculate the voltage drop across these two junctions. So what is the net reactance of the circuit? Net reactance is given by XL minus XC. Okay, generally what we are using in this formula, this is the net reactance. This is reactance, this is resistance. Combining both of them, you get impedance. Okay, so this is called reactance, net reactance. So net reactance is obviously 24 minus 16, which is given by 8. So what is the voltage drop? So voltage drop is across the capacitor and the inductor is given by current times net reactance. Okay. Normally in case of resistances gets added, but in case of reactances it gets subtracted based on the phase and the value. Okay, in this case XL and XC are always in opposite phase, but because XL is greater, we will take XL minus XC. In some cases, if XC is greater, we take XC minus XL. Based on the value of XL and XC, current lags or current leads based on the values of XL and XC. That's it. Okay, but this is always the difference between these two quantities. Okay, so I is 10, X net is 8, so the answer is 80 volts. So 80 volts is the correct answer. Option D, Anantha answered it. Yes, Anantha, correct. You are absolutely correct. Option D is correct. Now, next question. Which of the following combinations should be selected for better tuning of an LCR circuit? used for communication. So as you can see, different resistances are given, different L's are given, and different C's are given. Okay, so first of all, what should be the combination of what combination you should use that tuning of an LCR circuit. So you have to see what is the basic principle of LCR circuit. Okay, so there are two ways to determine it. First of all, if the frequency is given, if you know the frequency, then which of one of them will give you the correct resonance frequency. Based on that you can choose. Okay, but here frequency is not given. Okay, they have directly given you which of the following is better. So you can do what you can do, you can find the impedance. Again, impedance you cannot calculate. Impedance has to be to calculate impedance also you need to know the frequency, but frequency is anyway not given. So other way is to find the R value. If the R value is smallest, generally that will give you a smaller impedance, right? Because it is also includes R square. So one candidate is this one. Okay, and what else we have? We know that it is XL minus XC, right? What is the impedance of the circuit? Z square plus XL minus XC whole square. Okay, so if XL minus XC will also play some role, but because as we can see L value is given varies significantly and the frequency is not given, we will choose the smallest resistance in this case. So smallest resistance here is 15 ohm. So 15 ohm we will choose. Okay, there is otherwise if XL and XC is frequency is mentioned, okay, we will check if that is a resonance frequency or not. So that is condition number 1, and other than that we will choose the smallest possible value of Z. Sorry, I made one small mistake, that is it is R. Okay, Z equals to R square plus XL minus XC square. So we will try to find a value where R is small. Okay, smaller value means less distortion. Less distortion means we will get a good signal. So that is one of the ways to determine which circuit to use for resonance. Now next question. In an LCR circuit, Anantha again answered option D. Yes, Anantha, you are correct. Now answer this question. In LCR series circuit, the value of only capacitance C is varied. The resulting variation of resonance frequency F0 as a function of C can be represented as which of the diagram represents the correct value of variation of F0 with C. So F0 and C, how they are related? First of all, let us understand that. So frequency or resonance frequency is given by 1 by 2 pi square root of LC. Okay, so square root of LC is the variation. Now based on this relation, how can you determine which one will give you a correct relation between F0 and C? Which relation will give you a correct relation between F0 and C? Is it a curve like this? Is it a straight line graph? It is a decreasing graph or it is an increasing graph? Okay, let's see. Anantha is saying option C. Yes, option C is correct, because from there we can see that resonance frequency is inversely proportional to square root of C. So inverse proportional graph always represented by this. So this is definitely the correct answer. Now next question. The figure shows variation of R, XL and XC with frequency F in series LCR circuit. The for what frequency point is the circuit capacitive? So we have to choose. There are few points given in this circuit, A, B, C, D, and they asked you, and XL, XC, R values are given. As you know, R value is constant, XC is decreasing, XL is increasing. Okay, and they asked you for what value of frequency range, okay, the circuit is capacitive. Now what is the condition for capacitive circuit? The condition for circuit to be capacitive, XC must be greater than XL. If that is happening, then we say circuit is capacitive and current leads the voltage. Okay, if the circuit is capacitive, current leads the voltage. If circuit is inductive, then it is where we say current lags the voltage. Now as you can see that there is a way to guess the answer as well, even if you don't know. So you see that there are 1, 2, 3, 4 points. Okay, and this is the very important point. This is the point of resonance. Why this is the point of resonance? Because at this point, as you can see, XL is increasing, XC is decreasing. At this point, they are exactly equal. XL and XC are exactly equal. That means at this point resonance is happening. So when XL and XC cross over each other, that is the point of resonance. Before this point, each and every point XC is always greater than XL. And after this point, each and every point XC is always smaller than XL. Okay, so this point is resonance. Anything before the resonance is always XC is leading, XC is greater or circuit is capacitive. Anything after the resonance point, circuit is inductive, so inductance is leading. So definitely we can see that this is the point where circuit is capacitive, but option A is not given in option A. So be careful and answer the option correctly. Okay, yes, Anantha again answered correctly. So this is option C. Okay, so option C is the point where circuit is capacitive in nature. Now next question. In series LCR circuit at resonance, so as you can see, the resonance is the most asked question from this chapter. Every year at least one question you will get from resonance. Okay, in series LCR circuit at resonance, the phase difference between voltage and current is. So at resonance, what is the voltage difference between current and voltage? Okay, what is the by the way, what is the phase difference? Phase difference is given by tan inverse XL minus XC divided by R. Okay, so this is the formula for calculating the phase difference. Okay, so at resonance what happens? At resonance XL becomes XC, so XL and XC are equal, so this is nothing but tan inverse 0. So what is tan inverse 0? Tan inverse 0 is nothing but 0. So 0 means obviously the phase difference will be 0. So correct answer option D. Gagan came here and Gagan answered it option D. Yes, Gagan, you are absolutely correct. So correct answer is 0. Now next question. An ideal transformer has a turn ratio of 10 when the primary is connected to 220 volt 50 hertz AC source. The power output is. So they have given you a turn ratio, they have given you the input of the primary. Okay, and they asked you what is the power output. 1/10 of the power input equal to the power input 0, 10 times the power input. Let's see who can answer it. I will wait for some time. Anantha is saying option B. Yes, you don't need to read anything anywhere, you just read this term, ideal transformer. In ideal transformer, power in equals to power out. No matter what is the turn ratio, it is independent of turn ratio as long as it's an ideal transformer. So power input will always be equals to power output. So it will be equal to the power input. Now next question. Which of the following represents the variation of inductive reactance XL with the frequency voltage nu? Okay, so frequency of the voltage is given by nu, so that is F. We generally represent frequency by F, and inductance is given by XL. So how does XL and F varies? Okay, so XL and F, XL is given by 2 pi F into L. So what is the relationship? Relationship is XL is directly proportional to frequency F, or XL is directly proportional to frequency nu. So what would be the correct answer over here? Yes, correct. Option A. Ananta is again correct. Option A is the correct answer because they are directly related. Okay. Generally, most common graph related solution for KCET exam is this pattern. Okay. But there is some exception. For example, this is an exception where this is a pattern, but yes, it is obviously you can guess it, and this is the correct answer. Now let's move on to the next question. An alternating current is given by I equals to I1 sin omega t plus I2 cos omega t. The RMS current is given by. This is from question. This question is from 2018. Okay, an alternate current is given by I equals to I1 sin omega t plus I2 cos omega t. The RMS current is given by. So what is the value of RMS current? Okay, we know that if current is given by I naught sin omega t, then the RMS current is given by I naught by root 2. That is the normal formula. But if you see over here, here it is not a single sin omega t, but there is a sin omega t and cos omega t also. The currents are not constant. We have two different currents. Now how to answer this question? Now there is a complicated long process to solve it, but there is a shortcut way also that is being used by in mathematics. We have used in whenever we want to do some substitution method, especially for integration, this method is very common. So let's see what method I am talking about. So I equals to I1 sin omega t. Now maybe you know exactly the answer for this question, but if another question comes with the different values, different type of question, but the pattern is same, then you should know method how to solve it. Gagan and Anant both answered it. Let's see whether this is correct or not. So how to solve this question? So in this case, what you have to do, you have to substitute. I1 equals to I naught cos theta and I2 equals to I naught sin theta. So once you substitute these two in this equation, what you got? You got I equals to I naught sin omega t cos theta. I am just writing it so that you can identify it, plus I naught sin theta cos omega t. Okay, if you take I naught common, what is there inside the bracket? Sin theta, sin A, sin cos B plus sin B cos A, that is sin A plus B. So this is nothing but I naught sin omega t plus theta. Okay, so this is the current. Okay, and what is the value of I naught? I naught's value can be calculated by squaring both sides and adding them. If you square both sides and add them, you will get I naught square equals to I1 square plus I2 square. Cos square theta plus sin square theta is 1. So I naught will be square root of I1 square plus I2 square. We have done this multiple times in integration, solving integration problems. Also tan theta is equals to I2 by I1. Right? These methods are already known to us. So we just use this method, and from here we can say that the IRMS, we have calculated our standard form. Standard form was this. So we have calculated the standard form. So IRMS equals to I naught by root 2. What is I naught? I naught, we know this value. So it will be square root of I1 square plus I2 square divided by 2. This root 2 becomes under this whole root, and obviously this is the correct answer. Okay, so you should know the method how to solve similar question. Okay, this method is not exclusive in mathematics. This is sometimes used in physics as well. Now next question. A series resonant AC circuit contains a capacitor of 10 to the power of minus 6 farad. Yes, both of you, Gagan and Anant, both of you are correct. Now let's see the next question. A series resonant AC circuit contains a capacitor of 10 to the power of minus 6 farad and inductor of 10 to the power of minus 4 Henry. The frequency of electrical oscillations will be. So what will be the frequency of electrical oscillation? Frequency of electrical oscillation is given by 1 by 2 pi square root of LC. Okay, so resonant frequency, resonant AC circuit is mentioned here. So this is the resonance frequency formula. Okay, and capacitor is given 10 to the power of minus 6 farad, inductor is given 10 to the power of minus 4 Henry. So we just need to put those values over here and we get 1 upon 2 pi 10 to the power of minus 6 into 10 to the power of minus 4, and that will be 1 upon 2 pi 10 to the power of minus 10 square root. So square root means power will be half, so 2 pi 10 to the power of minus 5. Minus 5 will go up and become plus, so 10 to the power of 5 divided by 2 pi. So correct answer is obviously option A. Yes, Gagan and Anant, they answered immediately. Correct answer option A. Good. Now next question. Question number 12. In a series LCR circuit, R equals to 300 ohm, L equals to 0.9 Henry, C equals to 2 microfarad, and omega equals to 1000 radian per second. Then the impedance of the circuit is. So they have asked you about impedance only. So directly you have to calculate XL and XC. So what is the formula for XL using omega? Easy formula, XL equals to omega L, XC equals to 1 upon omega C. Okay, so what is omega L? Omega is 1000 radian per second, L is given 0.9 Henry, so that is 900. So 900 is the value of XL. What is XC? XC is obviously 1 upon 1000 into C is 2 microfarad. Micro means 10 to the power of minus 6. Okay. So be careful while calculating XC. XL is easy. So 1000 means 10 to the power of 3. So 10 to the power of 3, 10 to the power of minus 6. So it will be 1 upon 2 into 10 to the power of minus 3. So 10 to the power of minus 3 will go up and it will become 1000 by 2. 10 to the power of 3 means 1000, right? So this will be 500 ohm. So XL and XC are calculated. Now impedance time. How to calculate impedance? Impedance is given by square root of R square plus XL minus XC whole square. R is given 300, so 300 whole square plus XL is 900, XC is 500 whole square. Now you can take 100 is they are common in each and every term, and there is a square also, so 100 can be taken out of the square root and it will become directly 100. So what is left here? 3 square plus 9 minus 5. 9 minus 5 means 4. So 4 square. So 3 square plus 4 square is 9 plus 16, which is square root of 25. 25 square root means 5. So it will be 500. So these are the calculation skill that you have to develop quickly, that because 100 is common, we should take it outside the square root, and then whatever is left you have to calculate that, and this is very common square root. So correct answer option A, 500 ohm. Okay. Anant again answered option A. Now all of the last few questions are coming option A. Now let's see what is the answer for this question. This is very interesting question. Let's see who can answer this question first. Okay, what will be the reading in the voltmeter and ammeter in the circuit shown? So here we have a circuit where voltmeter and ammeter are shown over here. What will be the reading given here? If you see correctly, you don't need to do much mathematics over here. So XC is 4 ohm, XL is also 4 ohm. Okay, so this is a no mathematics question, no calculation question. Okay, I will not say mathematics question, no calculation question. Okay, so this voltage is given 90 volt. Okay, and what is the current? What is the voltage? This resistance is given by 45 ohm. Okay, so how to calculate it? Let's see who can answer this question correctly. Ananta is saying option B. Okay. So let's see. So obviously this is XL equals to XC. So if XL equals to XC, that means circuit is in resonance. So if the circuit is in resonance, the effect of XC and XL, they cancel each other out. So what is the voltage drop across XC and XL? What is the voltage drop? This is the voltage drop across XC and XL. So they are exactly opposite in phase. That means the total voltage drop should be equals to 0. Okay, so XC and XL, they will negate each other, right? Whatever voltage drop across XL, the same voltage drop will be across XC, but that will be in the opposite phase, so they will cancel each other out. So the total voltage drop across XL and XC will be 0. What about current? So in the circuit, only circuit is completely resistive, that means resistance is 45. So the current in the circuit is given by 90 by 45, so that is 2 amperes. So even if I said this is a non-calculative question, but you need a small, very small calculation to calculate the current. 90 by 45, which is easy. So correct answer is 0 volt 2 ampere. If the voltmeter is connected across the resistance, you would have got the exact 90 volt. Okay, but the voltmeter is not connected across the resistance, it is connected across XC and XL together. So that's why the voltage is 0. Okay, now next question. Gagan also came back and he answered it correctly. Now next question. See, again you see the same similar question pattern is coming again and again. Almost every alternate year you are seeing the question, again the same question. This question will be repeated again in another year as well. Let's see. A series LCR circuit contains inductance 5 millihenry, capacitance 2 microfarad and resistance 10 ohm. If frequency AC source is varied, what is the frequency at which the maximum power is dissipated? Just the language is changed. Maximum power is dissipated at resonance. We should remember that maximum power is dissipated at resonance. So basically that means the frequency they are asking to find is actually the resonance frequency. Okay, so we just need to calculate the resonance frequency in this case, and the formula is well known. So resonance frequency is given by 1 by 2 pi square root of LC. Resistance has no role to play over here, so only the inductance and capacitance is sufficient, so we will put that value. So 1 upon 2 pi, okay, L is 5 millihenry, 5 into 10 to the power of minus 3, and capacitance is given by 2 microfarad. 2 microfarad means 2 into 10 to the power of minus 6. Okay, 5 to the 10. So only the calculation is about tens. 10 to the power, calculating the 10 to the power value correctly. Okay, 10 to the power of minus 9. Okay, 10 into 10 to the power of minus 9, minus 3, minus 6. So it will be 2, 5. 10 into 10 to the power of minus 9 means 10 to the power of 8, and that square root will give you 10 to the power of minus 4. 10 to the power of minus 4 will go up and you will get 10 to the power of 4 by 2 pi. Now if you see the option, none of the option is given is this. Okay, so you have to convert this answer to the correct answer. So that's why I am giving you a few seconds to check which one will be the correct answer. Okay, just check the solution. None of the answer is exactly given as this, but you can convert this result into one of the given options. Which one is the correct answer? Gagan is saying B. Gagan, if you see, there is 10 to the power of 4 by 2 pi, B is 10 to the power of 5 by pi. There is no relationship between these two. Okay, so what you need to do, you just need to break this 10 to the power of 4 into 10 into 10 to the power of 3. That we can do, right? 10 to the power of 4 means 10 into 10 to the power of 3, so 3, 1 plus 3 is 4. So we can do that, right? So divided by 2 pi. So what we have done, we have taken 1 10 out of the 10 to the power, and then we cancel this using this. So we got this as 5 upon pi into 10 to the power of 3. Now if you see, you will see that option C actually matches with the given answer. So even after solving the question, that is a learning over here, that even if you solve some questions, you may not actually get exact matching. So you have to be patient and realize that you can further simplify that and you can find the correct match. Okay, that is how you can solve the question. Yes, Ananta came back and answered this correctly. Now next question is from 2021. A step-down transformer has 50 turns on secondary and 1000 turns on primary winding. If a transformer is connected to 220 volt 1 ampere AC source, what is the output current of the transformer? Okay, so what is the output current of the transformer? That is very, very important to give. So current is given, okay, the turns are given, voltage is given, okay, and it is saying that it is a step down transformer. So you can answer it even without thinking too much, but I would say try to solve it first, then you can answer it. Okay, so number of turns in secondary equals to 50, number of turns in primary is equals to 1000. Okay, voltage in primary is 220 and current in primary is 1 ampere. Now step down transformer means voltage goes down but current increases. Okay, voltage goes down but current increases. Normally for a transformer, okay, Vp by Vs equals to Np by Ns. Okay, this is the normal for voltages, but for current it exactly equals. So Ip by Is equals to Ns by Np. So for voltage it is directly related, but for current it is inversely related. Okay, so now Is will be equals to Np by Ns into Ip. Okay, do cross multiplication, comes over here. So Np is given here 1000, Ns given here as 50, Ip is given as 1. 0 0 cancels and you get this as 20 ampere. So 20 ampere is the correct answer. Okay, not 2 ampere, not 100 ampere. Okay, 2 ampere is the 20 ampere is the correct answer. So there is a way to guess in this case also. If you see 1 upon 20 and 20, so 1 upon 20 and 20 means one of them will be correct. So because they are very close to each other, the digits are closer, that means one of them will be very, very closer to each other. And if you realize that because it's a step down transformer, voltages is decreasing, that means current should increase. So that means it will be 20 ampere. This is also a logic to do. Hi Nagraj, you are late today. Welcome to the lecture. Only few questions are left. Okay, we have already solved 15 questions. Questions are very easy, not super difficult. Okay, medium to easy. Okay, from this chapter questions are not tricky at all. So far we have solved almost 15 questions. Now let's see this question. In the given circuit, the resonant frequency is, again a resonance frequency based question. So this is the third resonant frequency based question. Okay, only difference is in the result. Okay, last few options we have seen pi by 20, pi by 100, 10 to the power of 5 by pi. So whatever was there, but here they have divided it directly and given you the value. Also here instead of giving the values in a question, they have given a diagram. Okay, so same questions is coming almost every alternate year. Okay, so resonant frequency is very, very important from this chapter. Okay, this is an LC circuit. Don't worry, LC even though LC is no longer part of the syllabus, resonance is still part of the syllabus. Okay, so what is the formula for resonance? Again same formula, 1 upon 2 pi square root of LC. Okay, so now we just need to use this and calculate the resonant frequency. 20 microfarad, 0.5 millihenry. Okay, so resonance frequency is given by 1 upon 2 pi square root of 0.5 millihenry means 0.5 into 10 to the power of minus 3, and 20 microfarad means 20 into 10 to the power of minus 6. Now 20 into 0.5 is 10. 20 into 0.5 means 10. So this will be 1 upon 2 pi 10 into 10 to the power of minus 9. So that is, this is equals to 10 to the power of minus 8. Square root of that you will get 1 upon 2 pi 10 to the power of minus 4. So that means 10 to the power of 4 by 2 pi. So we have solved one previous question and we got the exact answer. Only difference is here, instead of giving the answer, instead of divided by pi, they have divided and given you the answer. But how to calculate? You do not have access to calculator. Then how can you calculate it without using a calculator? That is the major task. Okay, so F naught equals to 10 to the power of 4 means 10,000 divided by 2 pi. Okay, so if you cancel, you will get 5,000 by pi. 5,000, and what is the value of pi? Value of pi is 3.14. Okay, so this is the value. Now you have to decide which one is the correct answer. Okay, so for that you have to check how many figures your answer will have. If you see, all the data have different figures. So 1592, 15910, 15.92, 159.2. So all the result have different data, different digits. Okay, this has 4 digits, this has 5 digits, this has up to 2 digit is there. After that decimal, here up to 3 digit is there. After that this is decimal. So how many digit could be there in possibly in this figure? So as you can see here, we have 5,000 divided by 3. So if you take this number, round figure, say 4,500 or even 4,800, let's see, 4,800. So instead of taking 5,000, I am taking 4,800, and instead of taking 3.14, I am taking only 3. Okay, so if you cancel them, you will get this as 1600. This is the closest figure. We are not interested in exact figure. First of all, we will try to find the closest figure. So 1600 is the closest figure. Which one is closest to 1600? Only one which is closest to 1600 is 1592. So this is the correct answer. So 1592. So how we arrived at it? We just figure out that this must have 4 digits. So 4 digits should be the correct answer. Okay. Similar question, same question, again and again the same question is getting repeated. Okay, so this resonance frequency based question is coming again and again. So few days back someone was asking if questions repeat in KCET or not. So not exactly in the same form, but questions are coming repeatedly, this especially this question, resonance frequency based question. Okay, so, and even in 2 of the question we got the same answer. Okay, values, one case is the value was not calculated, in this case value is calculated. Okay, now let's see this question. In the given circuit, the peak voltages across C, L and R are 30 volt, 110 volt and 60 volt respectively. The RMS value of the applied voltage. Okay, Nagaraj, what you answered? 16A. Yes, correct, Nagaraj. Now answer this question. In the given circuit, the peak voltages across C, L and R are given. Okay, the RMS value of the applied voltage. So first of all, C, across C it is 30, across 3 it is 30, across L it is 110 and across R it is 60. So first stage to solve this question is find the net voltage, V, maximum voltage. Okay, maximum input voltage of the source. So voltage has some maximum value and some frequency, right? That is how a source is defined. So first we calculate the maximum voltage. How to calculate the maximum voltage? It is exactly same as the impedance formula. Okay, only instead of resistance etc. we will use voltages. So VR square VL minus VC whole square. okay, exactly the same as the impedance formula. So what is VR? VR is here 60 plus VL is 110 and VC is 30. Now again, if you see, all numbers have a 10 multiplication. So all numbers have 10 multiplication, means 10 will be coming out along with the square and it will come out of the square root. So basically you can say 10 square root of 6 square plus 11 minus 3 whole square. Okay, so this is easy peasy to understand. Now 11 minus 3 is what? 11 minus 3 is basically 8. So this will be 8 square. Okay, so 6 square plus 8 square, so 10, 36 plus 64, so it will be 10 into 10, that is 100. Okay, so 36 plus 64 is 100, 100 square root is 10, so 10 into 10, 100. Now this is not the answer. If you solve up to this point and then mark 100 volt, you will be 0, you will get 0 marks. This is not the answer definitely. Why? Because this is the maximum value of the voltage or peak value of the voltage, not the RMS value, because in the question it is mentioned peak voltages. So if peak voltages are given, you calculate the peak voltage of the source also. This is not RMS value. So what is RMS value? RMS is given by peak value divided by root 2 or 0.707 V naught. This is a factor. 1 by root 2 comes out to be 0.707. You can remember it. Or you just need to put the value of 1.4 as root 2 and calculate it. But this is also a standard way to solve. So 0.707 V naught we have calculated 100. So this will be 70.7 volt. Okay, so correct answer is 17C. Anand, as I mentioned, Nagaraj, as I mentioned, 17C will not be the answer because Ananta is answering it correctly. Okay, Nagaraj deleted his answer after seeing it. So you have to remember. Okay, so this question is slightly tricky. Why? Because even though answer is very simple, not difficult to solve, V naught you can calculate easily, but V naught is not what they have asked. They have asked here RMS value. Okay, so RMS value you have to divide your answer by root 2. That is the trick. Okay, so even though the answer is question is easy, but the trick is that even after solving this much, you may be lost and you may answer this question incorrectly because you forget that you have to calculate the RMS value, not the peak value. That's why 100 volt is given as an option. Okay, so this is the perfect distractor for this question. Okay, now next, the frequency of an alternating current is 50 Hz. What is the minimum time taken by current to reach its peak value from RMS value? This is the interesting question. Now peak value to RMS value. Okay, from RMS value to peak value, not from 0 to the peak value. That's why this question is slightly tricky. So let us understand. So if you see, this is somehow AC current looks like, okay, even though it is not perfect, okay, it's like this. So this is how an AC looks like. Okay, this is the peak value. Peak value is given by V naught. Okay, and RMS value is given by V naught by root 2. Okay, so this is the RMS value. This both side of the peak there will be RMS value. Okay, so this is the voltage, this is time. Okay, and they asked you how much time it takes to reach from RMS value to peak value. If it is starting from 0 to peak value, we know. Okay, time period, if we know the time period, T by 4 will be the answer for only 0 to peak value. But what about RMS value to peak value. Okay, so for that we will be using V equals to V naught sine omega t. Okay, this equation we will be using. Omega is 2 pi f. Okay, omega is equals to 2 pi f. F value is given, so it is 100 pi. Okay, don't worry about it. It can be solved easily. So first we will try to calculate the time that required to reach to starting from 0, how much time it takes to reach the RMS value. Okay, that is easier to calculate. So V naught by root 2 equals to V naught sine omega t1. Okay, so sine omega t1 equals to 1 upon root 2. Now what is the value of 1 upon root 2? It is sine pi by 4, the first angle, pi by 4. Okay, so pi by 4 we know, so from here we can say that omega t1 is equals to pi upon pi by 4. So t1 equals to here omega is 100 pi, so 100 pi t1 equals to pi by 4. So t1 equals to pi cancels, 1 upon 400. This is t1. Okay, this is interesting question. This is not a one-liner solution. Okay, so first we have calculated the time required to reach the RMS value. Next, from RMS how much time required to calculate reach the peak value, that we have to calculate. But first again, starting from t equals to 0, how much time it takes. So this value is calculated. Now we need to calculate how much time is taken to reach the peak value. So that is t2. Okay, so we know that V naught equals to V naught sine omega t. We are using the same equation. We are using, instead of V we are using V naught, because at this point the value of the voltage is V naught. So V naught cancels, we get sine omega t2 equals to sine 1. Sine 1 means it is actually either pi by 2, or a later stage it will be minus pi by 2, any one value. We are taking the positive value pi by 2. So from here we can say that omega t2 equals to pi by 2. Okay, or 100 pi t2 equals to pi by 2, pi cancels, and we get t2 equals to 1 upon 200. Okay, so what is the difference in time? Difference in time that we are trying to calculate. So t2 minus t1. Okay, from RMS to peak, from RMS to peak, this is the difference. In this case both are starting from t equals to 0. This is also starting from t equals to 0, this is also starting from t equals to 0. Okay, so t2 minus t1 is 1 upon 200 minus 1 upon 400, which will be 1 upon 400. Okay, you can calculate it. You will see that it will also come out to be 1 upon 400. That is 0.25 into 10 to the power of minus 2, or from the option 2.5 into 10 to the power of minus 3. So this is the correct answer. This much second is required to reach from RMS value to peak value. So this is RMS, this is peak. The time taken is 2.5 into 10 to the power of minus 3 seconds. Okay, this is how we should approach the question. Nagaraj answered correctly. Okay, Nagaraj, now let's move on to the next question. The readings of ammeter and voltmeter in the following circuit respectively. Okay, so readings of ammeter and voltmeter in this circuit respectively. Here if you see that VL equals to 50 volt, VC equals to 50 volt. So both VL and VC both are 50 volts. The resistance is given here as 100 ohm. This is given as 220 volt and 50 hertz. They asked you what is the readings of ammeter and voltmeter. Okay, so what is the meaning of 50 volt 50 volt? The meaning of 50 volt means, again this is a resonance based question. So when VL and VC are same, the circuit is in resonance. Okay, if VL and VC are same, the circuit is in resonance. So if the circuit is in resonance, what we can say is that the entire voltage of the source is actually applied across the resistor. They do not have a net voltage across them. Okay, so entire 220 volt is applied across resistor. So the reading of the voltmeter must be equals to 220 volt. Reading of the voltmeter must be 220 volt. What about the current? Current is given by the voltage divided by the resistance, because in resonance XL is equals to XC. So impedance, we do not need to calculate the impedance. R is given 100, voltage is 220. 220 divided by 100, that is 2.2 ampere. So ammeter will give a 2.2 ammeter reading and voltage will give you 220 volt. So in fact, if you have only calculated the current, you could have find the correct answer, because only one unique current is given as an option. Yes, Ananta, you are correct. Nagaraj also came in late, but you are also correct. Okay, now let's move on to the last question. Last but not the least, this is something interesting. Okay, I will give you some time, try to solve it and mention the answer in the comment below. An inductor of inductance small l and resistor capital R joined together in series and connected by a source of frequency omega. The power dissipated in the circuit is. So here we have a resistor. Oh, sorry, no resistor. One resistor, one inductor. So one resistor and one inductor, they are connected in series. Okay, and connected by a source of frequency omega. So here we have a source, resistance R, inductance L, and frequency is omega, angular frequency omega. They asked you what is the power dissipated in the circuit. So what is the power dissipated in an AC circuit? So that thing you have to remember. I am helping you. Power dissipated in an AC circuit is given by VI cos phi. Okay, VI cos phi. Cos phi is called power factor. If you remember, in resonance, at resonance, cos phi becomes 1. But here it is not in resonance, because obviously capacitor is missing. Only inductor cannot give you the value of resonance. So circuit is definitely not in resonance. So you have to remember the value of cos phi. That is the thing to solve it. But what we know so far, voltage is always voltage. Okay, voltage is given in the option as well. If you see in the option, current is not given, so you have to replace the current. So what is the current in a circuit? In AC circuit, current in an AC circuit is voltage divided by impedance. Okay, voltage divided by impedance is the current, and this is the current part. Now what about cos phi? Cos phi, if you have to remember, cos phi is given by R upon Z. Okay, cos phi is given by R upon Z. So this turns out to be V square R upon Z square. Now you have to tell me which one is the correct answer. Let's see. Ananta is saying option D, right? So here we have a Z square. So many students understand the fact and they somehow answer this one. Okay, because here there is no XC, so Z is basically given by square root of R square plus XL square. Okay, so square root of R square, and XL is omega L, so omega L square, so omega square L square. Okay, so this is the value of Z. So if you put that, you will get V square R divided by square of the square root, that means square root will disappear, you get omega square L square. So this is the correct answer. Okay, so power factor, if you consider the power factor, the answer will be this one. Okay, so this is the end of the lecture. Again, I request, if you are not part of our channel so far, don't forget to subscribe to our channel and also join the WhatsApp channel. The link of the WhatsApp channel is given in the description section of this video. I'll be back with a new lecture very soon. Till then, bye.